Assalamu alaikum. Hello, everyone, and welcome to Mathematics with Shahab Yaqub. Now, in today's class, we are focusing on S1, which is paper 5, that is statistics and probability. Representation of data. There are two kinds of question that we are focusing on. It could be about mean and standard deviation, whether it's a simple calculation, whether it's related to combined data. So let me just write over here data. And the second thing, this is about mean and standard deviation and coding. So now let's look at this first question. The question says, it says the amounts of money, X dollars, that 24 people. Now, the first thing that I'm interested in is underlining. So the amounts of money and that 24 people had in their pockets are summarized by such and such. Find sigma x and sigma x square. Now, it's a 5-mark question. So let's get started with the basic idea. Now, the very first thing is that what we do is that we write down the data. First of all, n equals to 24. And we are using this thing, let y equals to x minus 36. It's a question of coding. So which color are we using for coding? Purple and deep blue for mean and standard deviation. So therefore, this is this thing, deep blue for purple. This is for coding. And this is the coding that is being used. Y is x minus 36. Therefore, sigma y is equals to negative 60. Sigma y square, that is 227.76. Can I calculate y bar? Yes, I can. So y bar is sigma y over n, that is negative 60 over 24. And can someone give me this value? So this value over here, 60 over 24, how much is that? Is that 2.5? I think so. It is negative 2.5. Therefore, if I use the same equation, y is x minus 35. Let me 36, not 35. This is 36. Let me put a bar on it. So now the rule is for mean. Therefore, negative 2.5 is x bar minus 36. Take 36 to the other side. 36 minus 2.5 is x bar. Therefore, x bar is 33.5. Now, I'll pause it every moment and I would ask you to understand it. And there is no need of acknowledging it. So just focus on this. Is this step clear? The first step that was working in terms of y, and I got a y bar. So let me write in black color. This is y bar. This is y bar. This is step number 1. Step number 2, let me enlarge it. Step number 2 is related to this. That is work in terms of variable x, and hence you find the value of x bar. It's not over yet. We are interested in sigma x. So we know that x bar is sigma x over n, that is 33.5 is equals to sigma x over 24. Therefore, sigma x is 24 into 33.5, which comes out to be 804. That is the answer. That is step number 3. All good, all clear? So now, similarly, they want sigma x square. So step 4, that is work for standard deviation of y. Standard deviation in terms of y whole square, that is sigma y square over n minus y bar square. This is how much? This is 227.76. 227.76 divided by n, which is 24, minus y bar, which is negative 2.5 square. And we also know for a fact, step number 5, that a standard deviation of y square is equals to standard deviation of x square. Basically, both the standard deviations are the same. I'm just squaring it. So standard deviation of x square, that is sigma x square over n minus x bar square. That is sigma x square, which is the missing piece of the puzzle, over 24 minus x bar, which is 33.5 square. Again, have a good look at it. The steps are pretty basic, provided you can read and comprehend it thoroughly. You can strategize in your mind that this needs to be done first, and then this, and then this. So now what I can say is that s dy square, s dx square. Therefore, let me use a highlighter over here. This thing over here is the same thing as this thing over here. So just equate the two. You don't have to worry about what you call approximation at this stage. So therefore, sigma x square over 24 minus 33.5 square equals to 227.76, 227.76 divided by 24 minus negative 2.5 square. And then you can comfortably make sigma x square the subject. The basic maths, I leave it for you, and then you will get the answer. All good, all clear? So basically, you can say that this is step number 6, that you equate these two things, and then you will get sigma x square. Now, let's look at the mark scheme. In how much detail have they gone? Have they explained this thing in detail? So this is sigma x square, whatever is the answer. So I'm shifting to this thing. And the question was 18, I think. So now let me just capture this thing. And let me take it over there. And of course, it's not their responsibility that they should explain us all the steps. Their responsibility is also only to give us the answers. So they have done this thing in different ways. They have explained this thing, sigma x and sigma x square, and they have written in a very weird manner. So let me just pick this answer, 27011. This is 27011. That is the answer. Maybe the answer is exact. That's why they did not round off. So that is question number 18. That is done and dusted. Okay. Now, what do you think is the next question that we need to do? The next question is question number 10. Just have a good look at it. So now, this is question number 10. It says, Esme noted the test marks of 16 people. So this is the test marks of 16 people in a class. She found that sigma x is 824 and the standard deviation of x was 6.5. Calculate sigma x minus 50, sigma x minus 50 square. Now, again, this thing is about coding, but it's a twisted version. So it's kind of a slightly difficult question. So this is slightly more difficult than the rest. Now, the first thing, let's focus on this, the first part. Now, when we focus on this particular question, how should we approach it? We can approach it like this, that sigma x is 824. So n is 16. Sigma x is 824. We are interested in sigma x minus 50. That means from each value, all these numbers that added up, we need to subtract 50. How many numbers are there? 16. So therefore, this is 824 minus 16 into 50. That is 824 minus 800. That comes out to be 24. Just have a good look at it. How is this thing done? Sigma, this thing, that is equal to subtracting 16 pieces of information. So 50 was subtracted 16 times. 50 was subtracted 16 times. That is a subtraction of 800 from this thing. And that is how you get this particular answer. Now, what is the next thing? The next thing is this thing. That is, they are interested in sigma y square. Now, can we do this thing? This is, before that, one other thing. Of course, always mention let y is equals to x minus 50. So this is basically sigma y that we need to find. And this is sigma y square that we need to find. And now we have the standard deviation. So now the second part is not that difficult. The second part is this thing, that n is 16 and sigma y is 24 and sigma y square is unknown. And standard deviation of y is the same thing as standard deviation of x, which is 6.5, which is just one of the formulas that we used right over here. So you'll be using this thing. So therefore, S dy square is sigma y square over n minus y bar square. And this is 6.5 square. This is sigma y square. What is n? N is 16 minus y bar. That is 24 over 16. We know that x bar is sigma x over n. Y bar is sigma y over n. So 24 over 16, that comes out to be 1.5, 6.5 square, that is sigma y square over 16 minus 1.5. Don't forget the square. Make this the subject, 6.5 square plus 1.5 square. Put it inside a bracket, multiply with 16. That is sigma y square. Hence, you find the value of sigma y square. And that, I think it's coming out to be, you can double check, 1068. That is sigma y square over here. All good, all clear? So now, what is the next one? The next one is about that particular person. So this thing is done and dusted. Let's focus on this. One person did the test later. One person did the test later and her mark was 72. Calculate the new mean and the standard deviation of the marks of all 17 people. So now over here, let us work in terms of y. So we have sigma y old, that is for 16 people. That is how much? I think that was 24. That's right over here. This is sigma y. That is 24. Sigma y new should be 24 plus. The mark is 72. Subtract 50 from it. That is 24. That is 22. That comes out to be 26. All good, all clear? Similarly, the y bar new for 17 people. Now, old is for 16 people. New is for 17 people. This is sigma y over n, which is 24 plus 22. That is not 26, that's 46. So this is 46 divided by 17. Leave it as it is. What else do we need? We need sigma y square. I've pressed it too hard. Sigma y square old. That is this thing, this value. We calculated it over here. That is 1068. This is 1068. And sigma y square new for 17 people, it's sigma y square old plus subtract 50 from 72 and square it. So this is 1068 plus 22 square. That comes out to be 1552. So this thing is also done. Now let me highlight the major stuff. That is this thing. This is sigma y bar new. That is this thing. Sigma y new. That is this thing. And then we have sigma y square new. That is 1552. All good. Now what are we looking for? We are looking for standard deviation y square. That is sigma y square new. This is new divided by number of new minus y bar square new. So everything is new brand. That is 1552 over 17 minus 46 over 17 square. And now you can use a calculator, and let me go and check the working of question number 10. So this was 18 that we looked, and people can double check my working. And they have done I can see the first part only and not the second part. So the first part is only evident, the second part is not. And I think it's pretty good and all good, all clear. And that is the working for this particular part. So whatever is the answer, that will come out over here. So this thing is done. Now just acknowledge over WhatsApp. Let me just check. Okay, so this is question 18 and then question 10, both done. AS1, AS2. Okay. So this thing is all good, all clear. Now let me just check the WhatsApp. Somebody is saying that chat is disabled in Zoom. Yes, I do that because I just want, if anyone has a question, they can ask me on WhatsApp. That's the first thing. Yes, I'm recording so that some people can have a look at this video. No issue with that. Okay. Okay, all good, all clear. Now this is just an extra page, which I should delete right now. Okay, now let's look at all the formulas over here. Question 10, someone is saying this thing. Let me just double check. Okay, maybe some other working is there. Sigma y square. Maybe if there is any arithmetic working, just let me know. So let me just grab my own calculator. And over here, this thing is 6.5 into 6.5 plus 2.25. That is 44.5 into 16. This comes out to be 712. Okay, thank you. Some people pointed this out. So this is 712. This is 712. Thank you for that. And over here, this is 22 square, 22 into 22 plus 712. This is 1196. So let me just correct myself. This is 1196 over here. And those people who pinpointed this mistake, just double check. This is 712. And over here, I'm not writing the final answer. So this is 712 plus 22 square, 1196. So I think it's all good, all clear right now. Okay, ji, chale. Let's move on. Now, when we are dealing this thing, there are some extra formulas that we need to use. When we talk about raw data, we have one formula for mean, and that formula is this thing, which is x bar. That is sigma x over n, just the basic formula. This is for mean. And when we talk about standard deviation or variance, SD square, that is sigma x square over n minus x bar square. And if we want the standard deviation, we will apply the square root. Second thing, when we talk about frequency distribution, so for frequency distribution, we have the formula x bar that is equals to sigma fx over sigma f, which you have also used in O-level math. And similarly, for standard deviation square, we have sigma fx square. This is f into x square over sigma f minus x bar square. Now there are two new formulas that I need to introduce. First of all, for SD square, that is sigma x minus x bar square over n. I'll show you this, how to use this. And similarly over here, SD square, that is sigma fx minus x bar square over n. This, I'll just write it. We don't use it as such. So now over here, let's just focus on this. But before that, let me add a page. That basic example that we did last week, that was about 1, 2, 3, 4, and 5. 5 numbers. And we found x bar, that is sigma x over n. That is add all these up and divide by how many they are. So 1 plus 2 plus 3 plus 4 plus 5 divided by 5, that comes out to be 3. And one of the formula for standard deviation was sigma x square over n minus x bar square. That is added all up. That is 1 square, 2 square, 3 square, 4 square, 5 square divided by 5 minus 3 square. This is 55 over 5 minus 3 square, which is 11 minus 9, that is 2. So the variance SD square is 2. Therefore, SD is square root of 2. Now, let me solve the same question using another way. That is SD. I'm just focusing on this. SD square, it's sigma x minus x bar whole square over n. Now, what is the meaning of this? The meaning of this is subtract x bar from each value of x and add it up. Subtract x bar from each value of x and add it up. That is the meaning of this thing. So therefore, we have 1, 2, 3, 4, and 5. These are values of x. And if I write x minus x bar, the value of x bar is over here, which is 3. So subtract 3. 1 minus 3 is negative 2. 2 minus 3, negative 1. 3 minus 3, 0. 4 minus 3, 1. 5 minus 3 is 2. And let me add another column, another row, x minus x bar square. Negative 2 square is 4. This is 1. This is 0. This is 1. This is 4. If I add all this up, x minus x bar square, that is 4 plus 1 plus 0 plus 1 plus 4. 4, 1, 0, 1, and 4. That comes out to be 10. Therefore, standard deviation square is sigma x minus x bar square over n, which is 10 over 5, which comes out to be 2. Therefore, SD is square root of 2. So another way of working it out. Have a good look at it. All good, all clear? So now just acknowledge new raw data SD formula. SD formula, and that is what we have used right now. So new raw data SD formula. There is no compulsion by the examiner on exactly what needs to be used, but some questions could be worded in such a way that you should be well aware of this formula. Okay. So now this thing is done. Let me just recharge my pencil. And now, based upon this, let me first share with you this particular page. So this particular page, let me put my watermark on it. Okay. And let me share this thing with you, so you can understand it better. Okay. Sharing in the group. Okay. So now let's look at this particular question. Have a good look at it. This question over here. What is this question all about? This is question number 16. It says the ages. Now, this is about the basic stuff. So I think we are using this color. That is this blue over here. It says the ages of X years of 150 cars are summarized by sigma X is this, sigma X square is this. Find sigma X minus X bar, where X bar denotes the mean. Now, this cannot be done unless and until you are well aware of both the formulas. So we will write, first of all, SD square. So over here, SD square, let me use a thinner marker. SD square is equals to sigma X square over N minus X bar square. And similarly, SD square is equals to sigma X minus X bar square over N. Now, first of all, what is X bar? X bar is sigma X over N. So that will go over here. So over here, I can find it separately. So therefore, first of all, let me find that is equals to 645 divided by 150. So 645 over 150, I'm grabbing my calculator. 645 divided by 150, that comes out to be exact 4.3. There is no rounding off. So now I'll write it. Sigma X square, that is 8287.5, 8287.5 divided by N, which is 150, minus X bar, which is 4.3 square. This equals to what? That I'm writing in green, sigma X minus X bar square over N. The value of N is 150. So now just cross multiply, and 8287.5 over 150 minus 4.3 square, the whole thing into 150. You can simplify first, or you can use a calculator, whatever suits your need. X minus X bar square, and then you make this the subject and take care of the accuracy, and then you get the answer. That is question number 16 for you, according to the new formula. Now, this thing is done. Now, let's look at question number 39, a basic math question. Have a look at it. A very basic math question. It says R&D, Rani or Diksha D, go for shopping for clothes. So let's focus on the first part. Let me underline things. Rani buys 4 identical vests, 3 identical sweaters, and 1 coat. Each vest cost $5.50, and the coat cost $90. The mean cost, the average cost of Rani's 8 item is $29. Find the cost of a sweater. So let me just remove the colors and let me make it better. So first of all, 4 identical vests, it costs $5.50. And then there are 3 identical sweaters. We don't know how much is the cost of a sweater. Then there is this coat, and there is 1 coat, and the coat costs $90. And the overall average cost is $29. Now, first of all, what I'll do is that I'll write X bar is sigma X over N. X bar is 29, sigma X is sigma X, N is 8. 8 into 30 is 240. Subtract 8, that's 232. So therefore, this comes out to be 232. Sigma X is 232. That is the cost, total cost of 8 items. Now it says 4 identical vests. So that is 4 times 5.50. and 3 identical sweaters, 3 times S for the sweater. The cost is S. And 1 coat, that is 90, that is equals to 232. Basic math question. So therefore, this is 22. This is 3S. This is 90, is 232. Make S the subject. 3S is 120. Therefore, S is 40. Therefore, the cost of a sweater is $40. That is some basic stuff. The first part. Now, we are talking about the second person. And what is happening to the second person? That is Diksha buys 1 hat and 4 identical shirts. The mean cost of Diksha's 5 item is $26 and the standard deviation is 0. Explain how can you tell that Diksha spends 104 on shirts. Now, first of all, let me label this as 1. Let me label this as 2. When the standard deviation is 0, that means all the items are identical in price. We are talking about the value of price. This is $0. So all the items are identical in price. That means the hat plus 4 shirts. So basically the cost of hat and the shirt is the same. So hat plus 4 hat, that is equal to how much? That is equal to the average is there, 5 into 26. Because this is 5 items is 26. So 5 into 20 is 100. This is 130. 5H is 130. Therefore, H is 26. That means 130 minus 26, the cost of hat should give me $104. That is the cost of 4. What is that? That is 4 identical shirts. Or I can write it like this. I can write S and H are the same. So I can write S plus 4S equals to 5 into 26. 5S is 130, S is $26. 4 into 26, that is 4 shirts. That is 4 into 20 is 80. 4 6 are 24. 80 plus 24, that comes out to be $104. So that is some basic stuff that is done. Okay, now let's move on to the next idea. The next idea is about frequency distribution. So when we talk about frequency distribution, we want to work things in a very nice way. It could be ungrouped frequency distribution. I'll first do an example on this. Or it could be grouped frequency distribution. Now, what is the difference between the two? Let me add a page over here. Let's say I have a table, and let me draw the table in a vertical manner. So let me draw some horizontal lines first. And some values over here. No, this is a broken line. Okay, so let me write over here some values of X, some corresponding values of F. 0, 1, 2, 3, and 4. X could be anything, any variable, and the corresponding frequencies, let's say this is 5, this is 6, this is 8, this is 4, this is 2. Let me make some columns and I'll explain the necessity behind making these columns. Let me make a column for X square. Let me make a column for Fx. Let me make a column for Fx square and get your calculators ready. The square of X, that is square each one of these 5 values. That is 0, 1, 4, 9, and 16. Now let's multiply X and F. That is Fx. So 0 into 5 is 0. 1 into 6 is 6. This is 16. This is 12. This is 8. And let me multiply f and x square. So that is 0, and that is 6, and that is 16. 6 is there, 8 4s are 32. Let me correct this one. So 6 into 1 is this thing. I'm multiplying in this manner, and so on, so that I don't miss out anything. 8 4s are 32, 4 9s are 36, 2 into 16 is 32. And let me add few things. Let me first add sigma f, add up all the values. So 6 and 4 is 10, 8 and 2 is 10, that's 20, this is 25. Let me add sigma fx. So 8 and 12 is 20, 16 and 6 is 22, to 20 plus 22 is 42. Let me add these things, 32, 32, 64 plus 3600, beautiful number, and that is 106. Just double check my working first. I'm just waiting for some confirmation, and then I'll proceed. So now 8 into 4 is 32. Yes, it is 32. I just did that. I think maybe it's an old message. Okay. All good, all clear. So now let me just move on. And now what I'll do is that I'll focus on these formulas, which I have written over here a little bit while ago. That is this thing. So let me just pick this formula. No, not this thing. Okay. So I'm just copying this. And over here, I'm just pasting it a little bit smaller. Okay. So now I need to calculate x bar. So x bar is sigma fx over sigma f, which is 42 over 25. I'm grabbing my calculator. That is 42 divided by 25. This comes out to be 1.68. Let me also calculate sigma fx square over sigma f. So that is 106 over 25. 106 divided by 25. That is 4.24. And let me calculate standard deviation for x square. That is sigma fx square over sigma f minus x bar square. This is 4.24 minus 1.68 square. So 1.68 into, no, not 65, 1.68 into 1.68. That is 2.8224. This is exact. 2.8224, and this is 4.24 minus 4.24. This comes out to be 1.4176. So SD square is 1.4176. And if you are interested in SD, just take the square root, 1.4176, and you will get some value. So now that's how things are done. Now this thing over here, this is an ungrouped frequency distribution, ungrouped frequency distribution, because there is a single value of x. There are no class intervals, no class intervals, and we'll just talk about it, or class boundaries. All good, all clear? You just follow this procedure, make a column for x, this and this would be given. Maybe it would be given horizontally, write it vertically. Make a column for x square, x into f, that is fx, f into x square. This is not this. Let me write it. This is not fx, the whole thing square. This is f into x square. This is f into x square. Just fill it up. You need sigma f, you need sigma fx, you need sigma fx square. You just apply this formula. Let me make it a bit bigger. No, not this thing. And let me resize it. And that's how this formula is used. Now, what about this thing? which is grouped frequency distribution. Now, for grouped frequency distribution, we will use knowledge of O-level math. Let's say I have the data given 10 to 11, not 10 to 11, actually, this is 10 to 19, 20 to 29, 30 to 39, and this is class intervals. And let me change it into class boundaries, which we will be doing in the next class or so. That is, this difference is 1 unit. It's finishing at 19. It's starting with 20. The difference is 1 unit. So we add and subtract 0.5. The lower class bound, the upper class bound, something like that. This is 9.5 till 19.5. This is 19.5 till 29.5. This is 29.5 till 39.5, and so on. If I take the mid value of 10 and 19, half of lower class interval plus upper class interval, that is half of 10 plus 19, which is half of 29. That comes out to be 14.5. And if I use this thing, that is half of lower class boundary plus upper class boundary. That is half of 9.5 plus 19.5. And if you look at it very closely, if I just take this 0.5 over here, this becomes 20, 9.5 and 19.5. So this is 20 plus 9, 29. That is half of 29. Of course, this is also 14.5. That means I can calculate the mid value from either one of them. I am interested in the mid value X, whether you calculate it from lower class interval, upper class interval, they average, or lower class boundary, upper class boundary, they average. So this is about average. Why? Because if you get a grouped frequency distribution, which could be about class interval, which could be about class boundary, maybe in one of these questions, it's finishing at 30, starting at 30, you need the mid value to work it out. So let me make a column for X, the mid value. 21 plus 40, 61, 61 divided by 2, that is 30.5. 41 and 45, let me add it up. So this is 41 plus 45, that is 86 divided by 2, that is 43. And then 46 and 50, that is 96 divided by 2, that comes out to be 48. I'm just writing the mid values. 51 plus 60 divided by 2, add it up, that's 55.5. And 61 plus 80, how much is that? 61 plus 80, that is 141 divided by 2, that comes out to be 70.5. Now this is your X and this is your F, and then you would make the same working like over here. A column for X, a column for F, a column for X square, a column for Fx, a column for Fx square. Let me show you a little bit of the working. So now I have 5 values, 1, 2, 3, 4, 5. So let me just make few lines over here. So 1, 2, 3, 4, 5, and let me do one more, that is 6. So let me write over here, this is X, this is F, this is X squared, this is Fx, this is Fx squared. X is 30.5, 43, 48, 30.5, 40, what? 43, 48, 43, 48, 55.5, and the last one is 70.5. And over here, the corresponding frequencies, that is 18, 15, 21, 52, 28, 18, 15, 21, 52, 28. And just start working for all of them. For example, 30.5 into 30.5, I'm just finishing this up. That is 930.25. 43 into 43, that is 1849. Don't forget there is a decimal over here. Then there is 48 into 48, that is 2304. 55.5 into 55.5, that is 3080.25. 70.5 into 70.5, that comes out to be 4970.25. 4970.25. This is x squared. And then this one over here, when you multiply x, let me choose another color. When you multiply x with f, that is fx. When you multiply f with x squared, that would be fx squared. And then you would add it up. So this is sigma f something. This is sigma fx something. This is sigma fx squared something. And then we would use the formula x bar sigma fx over sigma f. We would use the formula standard deviation square is sigma fx square over sigma f minus x bar square. And that's how you would calculate mean and standard deviation. So I'm just interested in this thing. Calculate estimates of mean and standard deviation of these height for 5 marks. This is 5 marks out of 50. Yes, a lot of work is there. And just have a look. They have written it like this. They have written this is x, this is f. Let me use red color. So over here, this reddish one, this is the value of x, 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 and the blue one, that is this thing, the corresponding frequencies. So this first thing that they have done, this is x bar, which is sigma fx over sigma f. They have not drawn any column. Okay, and that is the answer. Now, variance is SD square. So this is, again, let me focus on this. Let me choose a red color. This is 30.5 square, that is x square. This is 43 square. This is 48 square. This is 55.5 square. This is 70.5 square. And we are multiplying it with the corresponding frequencies that you can see over here. And this, what they have done is that this is x bar square. They have done the subtraction over here. And that is how you get standard deviation. So I prefer things to be done in a very neat manner so that the examiner is ready to give you full marks. It's the same question over here. It's again a group frequency distribution, 0 and 30, the mid value is 15. 30 and 50, the mid value is 40. 50, 70, mid value is 60. 70, 90, 160, the mid value is 80. 90 and 140. Let me add this up. 140 plus 90, that is 230 divided by 2, that's 115. So again, the same process will be used over here. This is x, this is f, and we are focusing on this thing. Calculate a median on the mean amount. So therefore, x bar, they're not asking for standard deviation. Let me just calculate x bar, which is 15 into 16, which is 40 into 40, which is 60 into 48, which is 80 into 26, which is 115 into 30. Add it all up, divided by sum of frequencies, which is how much? Which is written over here, 160. And there it is, 15, 16, 40, 40, 60, 48, 80, 26, 115, 30, divided by 160. And you get this answer, correct to 3 significant figures. So we are done and dusted with all the concept of mean and standard deviation in 4 hours. 2 classes of 90 minutes and 1 class of this one. So till the very next class, stay tuned for more content.